Myself, Benilda, Assistant Professor in the Department of Artificial Intelligence and Data Science at Sri Muthukumaran Institute of Technology. Today we are going to learn the subject 3D Printing and Design. The subject code is CCS 331. In the previous video, we have seen Unit 2, the extrusion-based 3D printing and wire-based 3D printing. In this video, we are going to see granular-based 3D printing. This granular 3D printing is also called as powder-based additive manufacturing, as it uses fine powder particles as the raw material. In this process, a thin layer of powder spread evenly over a build platform to form a powder bed. A heat resource such as a laser or binder selectively fuses the powder particles only in the areas required for the part. Once the layer is completed, the platform moves down and a new layer of powder is spread. This layer by layer fusion continues until the full object is formed. The surrounding unfused powder supports the part during printing, eliminating the need for the additional support structures. This granular 3D printing is widely used in industries such as aerospace, healthcare, automotive, because it offers high precision, excellent mechanical properties, and the ability to produce complex geometries. In this process, a thin layer of metal or polymer powder is spread over the build platform, and a high energy source such as laser or electron beam selectively fuses the powder in the required areas. After one layer is completed, the build platform moves downward and a fresh layer of granules is spread. This process continues until the final part is formed. The common technologies based on this method include selective laser melting and electron beam melting. Next, the working process of granular-based 3D printing. First, a 3D model of the object is created using a 3D modeling software and saved as a STL file. This file is then sent to the 3D printer's interface software, where the model is sliced into thin layers and the printing path is defined. During printing, a thin layer of material such as a plastic or ceramic powder is spread over the build area. The required regions of this powder are fused together layer by layer to form the part. The surrounding loose powder supports the component, so no additional support structures are needed. This process is repeated for each layer until the complete part is formed. This diagram illustrates the powder-based fusion process used in metal 3D printing. First, a thin layer of metal powder is spread evenly over the powder bed using a depositor or leveler. Then a high energy laser beam scans the surface and selectively melt the powder according to the part design. The melted powder solidifies to form one layer of the component. After this, the build platform moves downward and a new layer of powder is spread. The laser again melts the required areas. This layer by layer process continues until the entire component is fabricated. The surrounding unmelted powder supports the part during printing, eliminating the need for additional support structures. Next, we can see the common material used here. So the granular based 3D printing can process a wide range of materials, making it suitable for many applications. The common plastics used include nylon or polyamide, which offer good strength, flexibility, and wear resistance. Metals such as steel, aluminum, and titanium are also widely used, especially in aerospace and automotive industries, because they provide high strength, durability, and heat resistance. In addition, the ceramics and sand are used for applications like molds, casting cores, and high temperature components. The ability to print with different materials allows granular 3D printing to produce functional, high performance parts with complex geometries. Next one is the working principle of granular 3D printing. See, this granular 3D printing is also known as powder-based additive manufacturing, and it uses fine powder materials such as plastics, metals, or ceramics to build the objects layer by layer. So the first one is powder deposition. First, a thin and uniform layer of powder is spread over the build platform using a roller or blade. This powder forms a base for printing and provides support for the part during the process. Next one is selective binding or melting. So the specific regions of the powder layer are solidified according to the digital design. This is done in two main ways. First way, a laser or electron beam melts or sinters the powder particles together, as in selective laser sintering. Second one, a liquid binder is sprayed to glue the powder particles together, as in binder jetting. Only the required areas are solidified and the remaining powder stays loose. Next one is layer addition. After one layer is completed, the build platform lowers slightly and a fresh layer of powder is then spread evenly over the surface. Next one is repeating the process. After one layer is completed, the build platform lowers slightly and a fresh layer powder is then spread evenly over the surface. Repeating the process. Steps of selective binding, melting, and layer deposition are repeated continuously, and gradually the object takes shape from the bottom up, fully embedded within the powder bed. Finally, the post-processing. Once the printing is finished, the unused powder is removed and reused. The printed part may then undergo sintering, polishing, heat treatment, or machining to improve the strength and surface finish of the material products. Next one, how it works. So simply to say, the process starts by spreading a thin layer of powder evenly on the build platform. A laser is then used to selectively join the powder particles only in the areas that form the part. Once the layer is completed, the build platform moves downward. The fresh layer of powder is spread on the top and the joining process is repeated. This layer by layer operation continues until the entire part is built. The unused surrounding powder supports the component during printing, so the additional support structure are not required. So the types of granular based 3D printing processes. So these are the types: selective laser sintering, then selective laser melting. It is also called direct metal laser sintering. Then electron beam melting, finally binder jetting. So these are the types of granular based 3D processes. Next, the advantages. The granular based 3D printing offers several important advantages. Since the unused powder surrounds the part during printing, no extra support structures are required, which reduces the material waste and post-processing. This method allows the production of complex geometries and internal features that are difficult or impossible to make using conventional manufacturing. The parts produced have good strength and high dimensional accuracy due to precise layer by layer fusion. Because of these properties, granular 3D printing is well suited for producing functional and end-use parts in industries such as aerospace, automotive, and healthcare. So some of the limitations. Although the granular based 3D printing offers many advantages, it has some limitations. The machines used in this process are expensive, which makes the initial investment high. After printing, the post-processing steps such as cleaning, sintering, or heat treatment are often required to achieve the desired strength and surface finish, which increases the time and cost. In addition, the powder handling requires special care because fine powders can be hazardous, needs controlled environments, and must be stored and recycled properly. These factors can make the process more complex compared to other 3D printing methods. So finally, the applications. It is used in aerospace and automotive as it is a lightweight metal parts and engine components. Then in medical and dental fields, this technology enables the production of customized implants, prosthetics, and surgical tools tailored to individual patients. In jewelry and fashion, this granular 3D printing allows the creation of intricate metal and ceramic designs with high detail and accuracy. Additionally, in industrial manufacturing, it is used for rapid tooling, molds, and spare parts, reducing production time and costs. So in the next video, we can see about lamination based 3D printing. Thank you.